Everyone is hearing me? No?
Yes, yes, hearing you now.
The Bluetooth device is connected successfully.
So we're just gonna continue into the hybrid introduction. All right. Thanks. So electric and non-electric vehicle. An electric vehicle has one moving part. So we're doing like a quick comparison here. So an electric vehicle has one moving part, the motor, whereas the gasoline powered vehicle has hundreds of moving parts. All right. So the electric vehicle requires less periodic maintenance as more and is more reliable. All right. So for example, like Tesla, with the brake check like once per year, versus the traditional ICE vehicle, probably every 6 months. Well, depending on driving, how the person drive. All right, so as also with the electric vehicle, only one moving part, and that is the motor. While with the ICE vehicle, we use hundreds of moving parts. All right, so it's a hybrid, and HEV, shortening or abbreviation. So hybrid electric vehicle are powered by an internal combustion engine in combination with one or more electric motor that uses energy stored in batteries. Hybrid electric vehicles combine the benefits of high fuel economy and low tailpipe emission with the power and range of conventional vehicles. So as also we have a pure electric vehicle and we have a hybrid. So the hybrid is a fusion between electric and ICE vehicles. Right? So with the combination it still go outperform a pure ICE vehicle because we're gonna have less tailpipe emission. Or probably gonna get the same power output or more. All right, and better fuel economy. And this is a layout of an hybrid. So as I can see, we have our high voltage battery, sometimes called traction battery. All right, and we have our power electronics. So that's like our modules, and that will be like monitoring battery temperature, battery current, state of charge, state of health, of the battery itself. And it gonna use those data now to actually tell the engine when to switch on, when to switch off, when the battery cooling fan should come on. So in it, all of the electronics. So that's the brain right there. And after that now we have our electric generator, which is the internal combustion engine right there. And then we have our power split device, and we have our electric motor. We have our chain, and we have our gear reduction. So anybody want to tell me what the gear reduction is or what it is acting as? In a regular vehicle, would I call it a different name. In ICE vehicle, internal combustion engine vehicles, but in hybrids and electric vehicle, call them gear reduction or reduction gear.
I guess the gear reduction would actually be the differential or the diff.
Close enough. Yeah. Alright, so the diff right here, what I call it the final drive. So if I have this as the final drive or the diff, what would I actually call the gear reduction?
Like a planetary.
Which part we normally find the final drive?
Gear reduction would I call it, say that would that be the transmission.
seeing the screen.
Alright, my apology for that. I just have some technical difficulties. Yeah, so we'll discuss this image here. Yeah, so the gear reduction or reduction gear, as I said, that would act as a transmission in this case. So the reason why you're not gonna see it have like a lot of gears in it, because the motor can actually spin at variable speed. So the motor itself will actually act as a gear reduction as well. So that's why you can still get the full range. But at the same time, them are gonna have them limits. Because for example, if a Tesla should like go down the quarter mile, it's gonna have a certain time where it's gonna tap out at higher speed. Right? While the conventional vehicle, you can actually change the gear ratio to actually go more miles per hour. So with these, the maga have them limitation as to where the maga tap out. Alright, so we have gear reduction acting as a transmission, then we have a final drive, and then our road wheels. So the key thing right here says the power splitter. So once we have like a hybrid vehicle, we always have a power splitter. And what that does is you can split the power between the engine and the traction motor, meaning you can use both the engine and the traction motor to propel the vehicle. So for example, if you climb a hill and the computer calculates the engine are gonna need assist, the motor can actually assist the engine. Right? Or if you move from a dead stop, the motor can actually assist to move, as well as the power split can act make you get power from the battery itself or from the engine or both, as well as you can propel the vehicle and a charge the vehicle at the same time. So the splitter would be like the middle press distributing or regulating the power between the two on the road wheel. All right. I think more than that. Or 9. All right. So with the hybrid system or pure electric vehicle, we have our charging system. Yes, so the charging system we know say in our ICE vehicle would have for alternator for the charging. But when it comes to hybrid and electric vehicle, we don't use a alternator to the charging. We use our DC to DC converter. And what that does, it converts a higher voltage to a lower voltage. And that lower voltage will be like 14 or whatever is required to charge the battery and power the auxiliary system like the headlight, radio, and all those other stuff. All right. So you can charge an electric vehicle by plugging in into a public charging station or into a home charger. All right, so how far can you travel on a full charge depends on the vehicle. each model has a different range, battery size, and efficiency. So this charging system here, the Motovehicle now is like the actual plug-in system where they use to charge the vehicle itself, right? And yeah, you have some hybrid vehicle that you can actually plug in and charge, while others use the engine itself, charge back itself. So you have two different type of hybrid. You have plug-in hybrid and hybrid vehicle. So all electrical pure electric vehicle and battery electric vehicle, same thing, just different wording. It's a pure battery electric vehicle, same thing. Once you see that, they're referring to the same thing. So plug-in electric. This means the car runs purely on electricity and gets all its power when it's plugged into a charge. Yeah, man. So once it is a plug-in electric, it means that it gets all its energy from a battery, right? It has no engine, nothing like that. So, so once you run out of charge or you're low on charge, you have to go to a charging station. So as I say, I'm a plug-in electric. This means a car runs purely on electricity and gets all its power when it is plugged into a charge. Note brief, this type doesn't need petrol or diesel to run, and therefore it does not produce any emission like traditional cars. So we have like with Tesla and with BYD, Build Your Dream, and some other vehicle that is just pure electric, Nissan Leaf, and the NV200 zero emission. So once it's a zero emission and the back of the car, say it's a pure electric. All right, so this is a layout of a pure electric vehicle. So as I can see at the front here, we have our thermal system. So we have like our radiator, cooling fan, condenser, and stuff like that. And here we have our DC to DC converter. And as I said, this replace or act as a alternator in this case. And then we have our power electronics controller. Right, so that's the brain right there. Then we have our electric traction motor. Right, normally a 3-phase motor. And then we have our auxiliary battery. Same thing as a 12 volts. As I said, the name are gonna be between 12 volt and auxiliary battery. So once you see the term auxiliary, we'll say it's a 12 volt battery we're referring to. And then we have our onboard charger. And the onboard charger is actually, well, that allows it when you plug in from an AC source like your socket at home, the onboard charger now actually change that AC voltage to DC, right? And it actually sends the type of charger that is being plugged in, right? And the rate at which that charger got charged. So it actually put the vehicle in charging mode. So it's just like when you plug in your phone, the phone now will actually sense if it's a fast charger, if it's a slow charger, and so forth, or it can actually tell you if you're using the wrong type. So that's what the onboard charger actually does. And so we have our transmission here, which is the same thing as the gear reduction gear. And then we have our traction battery. So with the pure electric vehicles, the traction battery normally mounts under the vehicle. So this is why I was telling you that you have to be careful when jacking them up. I think like 80% of these electric vehicles, all of them use the same platform or chassis. Them get them chassis from one manufacturer, so the base of them are almost be identical. Just the body frame and style probably different. But Tesla is different from the rest though. And I'm not sure if other manufacturers actually start to manufacture their own chassis. So we have our extended range. So when it comes on to EV, we can actually put them into different categories. So extended range is one category. So we have so extended range electric vehicle is effectively an all electric vehicle with all the motive power provided by an electric motor, but with a small ICE present to generate additional electric power. And as I said, the ICE is the internal combustion engine. So in this case, even though the vehicle comes with internal combustion engine, it is still classified as a pure electric vehicle. Meaning, reason being, the engine itself does not provide power to the road wheel. It has nothing to do with the propulsion of the vehicle, right? The motor does all of that work. The only purpose for the IC engine is to charge back the battery. So in this case, you don't have an onboard charger, in other words. So alternatively, it may be viewed as a series hybrid with a much larger battery. So we know so hybrid vehicle use a small battery pack, whether it's under the back seat, in the trunk, at the back seat rest, and so forth. But with the pure electric vehicle, you use bigger battery stack, right? So try and remember that extended range. It uses a small ICE engine to recharge back the traction batteries. So we can actually look at that as a series hybrid. But unlike hybrid vehicle, you can switch between engine and motor to actually propel the vehicle. In this case, we won't have any switching back and forth, so we wouldn't need a power splitter in this case. If you guys have any questions, I can ask.
Sir, the extended range, the ICE sound like a generator. So you need to constantly put gas into it.
Yeah, you still don't need to put gas in it because we have an ICE engine on board. So whether it want to be diesel, whether it want to be gas, whether it want to be hydrogen, you would need to supply the ICE engine. So that would have still needed basic maintenance like oil change and so forth. But it still would have outperform a pure ICE vehicle, because at least you wouldn't have the engine revving. It will just be at like a steady pace, just like a normal generator. So you would have lower emission, and of course it would have switch on and off based on power demand. But it would have an advantage over pure electric vehicle, because you know the pure electric vehicle, when you run out of range, you'd have to go try find a charging station. So if you go far distance, you'd have to plan a route where and where you can get charged and stuff like that. While with the ISV, the extended range, you don't have to worry about charging interval during your journey. You just have to worry about just adding gas to it, and you know we have a lot of gas stations, so you'd have an edge right here. So you're like you get best of both worlds.
And then clearly the extended range vehicles will be a little more expensive than the straight ER vehicles. I mean EV vehicles.
All right, repeat that again.
I was saying that the ER vehicles would be a little more expensive than the straight EV vehicles, I would think, just for that because they have that feature or that option.
Well, not necessarily.
Oh, okay.
Yeah, not necessarily.
Okay.
Sometimes you will find them more affordable, because the reason why you will find them more affordable, but them will come with less battery pack. It's a smaller battery pack.
Oh, yeah, that makes sense.
Yeah, so you know, say the battery will bring up the price.
Right. True.
Yeah. Yeah, so you just put in a smaller battery and just constantly have them on charge in comparison
Right.
to a electric vehicle where the entire floor of the vehicle is covered in battery.
Right.
Yeah. All right, so extended range. So when the battery is discharged to a specified level, the IC is switched on to run a generator that in turn supply power to the electric motor and or recharge the battery. With this arrangement, the range limitations that is inherent in a battery electric vehicle can be overcome. So as I was saying, them do this to actually overcome the limitation of the pure electric vehicle or the battery electric vehicle. All right, so it's like them would have see the weakness or the disadvantage of a pure electric vehicle and just add a generator to it. And at the same time, it's actually give buyers option, because you will have one person who will prefer the pure electric vehicle, because probably them cover like shorter distance during the day, probably like from work to home, and the range is short, so them only need to have an ICE vehicle, while you will have one set of person who travel from here to Montego Bay probably twice a day or something like that. So the extended range would have probably suit them, while you have an next person who would have prefer to go with the hybrid. So it's like it gives people choice. So instead of say, right, well, I forgot pure electric, some people still like to hear the sound of an engine. So they would get the best of both worlds same way. Option, as I said. All right, so still an extended range. So with the electric vehicle now, there is a thing called regenerative braking, meaning once you step on the brake pedal, the battery will actually start to charge, and the engine can actually switch on, and you get the battery charging without the engine running. And and that process is like, so for instance, you ever driving a standard vehicle, and like you leg off for the throttle, and then and keep the vehicle in gear, and you feel the compression on the engine. say that use the compression of the engine to slow down the vehicle. In this case, when you do regen braking, once you let go the brake pedal, the motor inside the motor get power from the battery. The motor itself now go act as a generator. So the road instead of the motor turning the road wheels now go in turn and turn the motor. But it go have some resistance to go slow down the vehicle. So once the road wheels start to turn the motor now go act as a generator and send back current to the battery. But it go pass through the inverter first, because I know AC voltage it go produce. And now the DC voltage you can store. So it go invert that and send it back to the battery. So that's how the regenerative braking come in play. Right? So when you step on the brake pedal, the brake pads not necessarily go lock against the rotor. And the motor itself will actually slow down the vehicle. But based on the demand or the aggression in which you step on the brake, the calipers may actually slow down the vehicle. Alright, so if you just a shadow the brake, what the motor will do is slow down the vehicle and then in turn charge back the battery. Right, so you will find, say, if you travel at like on the highway and not using much brake, you will find, say, you actually are gonna lose battery charge or range quicker than if you did a step on the brake, like driving through the city or driving on the whole bypass. You will actually helping to charge the battery by using up the brake. Alright, so as I can see, the line is going down, meaning decelerating. So we have our charge depletion right here. Engine is off, right? Even though regen braking can occur while the engine is on scene, it doesn't matter. And right here now we have our extended range mode, engine generator on, charge sustaining. So engine will be off at certain time. So that much for the time when the engine is off and when it is on. And once you go over in the green section now, this is our charge mode. So this is when the vehicle is parked, electric onboard charger from power grid. So you actually plug into a power grid to charge. So we get charging from regenerative braking or our onboard ICE engine or from an external source, a power grid.
So that means if you should push or send the car down the hill and brake long enough, you can create enough energy to drive if the battery is completely dead.
Yeah. It go actually charge the battery to some extent, but it probably not gonna charge it as fast as the engine would or an external source would.
And it would have to be aggressive braking.
No, but a more aggressive braking, I go slow down the car more. Even though it go spike the charging, of course, but it's just that it go actually come to a stop, because what got me now, the computer now will actually command the brake itself, the hydraulic part of the system, to actually come in play.
And it
Because it
more
actually
electricity.
it's like an emergency, probably something in front of you, so the vehicle will actually stop based on the input, the pressure input. But if it's a case where you just a shadow the brake, it will actually the region, because it go know, say, well, you don't really want to come to a full stop, you just want to cut momentum. But if you brake more aggressive, it will just brake like normal and stop the vehicle. Because you only want to brake hard and then it's still there, I go. Because based on your pedal inputs, that a way it will sense from it, so you need to stop now. Alright. Alright, so this is region so we have a regenerative braking right here. So this is how it actually happen now. So we normally have power coming from the battery going into the inverter, right, and to the electric motor. But in this case now, when we let go the gas pedal, you just want to let go the gas pedal or touch on the brake. Where you find now, you're going to find power now move from the road wheel and going to the battery itself. So it's like the opposite. How would normally happen when you step on the gas pedal? When you step on the gas pedal, power leave the battery, go to the traction motor. When you step on the brake pedal, it leave the motor, go back to the traction battery. Alright. So this is actually an extended range, as I can see, because we have our ICE engine at the back. We use gas E85, E100, and all of those are ethanol. However, diesel and biodiesel. So it can be just about any type of engine or generator.
So, sir, sorry. On all of the vehicles that use batteries, you'd refer to the battery pack as a traction, what do you call it?
Traction battery.
Traction, okay.
Yeah. Because
All right.
them because them actually refer to the motor not just as a motor but as a traction motor, meaning that it will provide traction to the wheels. So
Right.
them will call the battery traction battery. And then
Okay.
instead of say 12-volt battery for our regular battery, them say auxiliary battery. So
Okay.
that's the term them change, but are the same. But those are the terms where you're gonna normally see. Traction battery, traction motor, and stuff like that.
Okay.
Yeah.
Sounds
And them are gonna use mostly abbreviation like range extended vehicle, electric vehicle. So instead of write it out, them are gonna just and so we have extended range vehicle and we have range extended vehicle, and they are almost like the same. So a range extended vehicle, electric vehicle, or an extended range electric vehicle is a battery electric vehicle that runs on electricity but includes an auxiliary power unit known as a range extender. The range extender, usually a small petrol engine, drives an electric generator which charges a battery that supplies the vehicle electric motor rather than driving the wheel. This allows for an increased range from the vehicle. So if you say range extender and extended range, they are almost like the same. They have a onboard ICE engine will supply power to the traction battery, and the traction battery provides traction to the road wheels. So them not nothing for do with the movement of the vehicle itself. As I say, it's just a charger, onboard charger. All right. So if you see REEV and EV are the same thing. Range extender or extended range, same thing. So extended range electric vehicle reduce emission because they can be operated in zero emission mode for around 50 to 100 miles before the range extender engine is used. So them have a range up to 50 to 100 miles, and that go depending on the traction battery size before the ICE engine actually chips in. So them can go into zero mode, full stealth mode. So that will actually help with emission and fuel consumption will be way better. All right. And the Nissan Lee, the Nissan e-Power, the e-Power Note. I don't know if any of you guys ever see that on it. You have the regular Nissan Note. That's the new shape 2014 upwards. You know what? We are familiar with Nissan Notes, right?
Yes, sir. Yes, sir.
Yeah. You have so you have one that is called Note e-Power. So the e-Power Note, it mark e-Power on the side door. That one is actually a series hybrid or extended range hybrid, meaning it has a regular ICE engine, but as we know, the ICE engine is only acting as a generator. So when you see a Nissan Note Mark E4, that is an example of one. Or any Nissan you see Mark E4, it's a range extender. Once it marks zero emission, it's a pure electric. So you can use a badge on the vehicle to actually identify what type of electric vehicle it is. All right, so range extended electric vehicle. All right, so it's a technical concept tree. Yeah, man. So as you can see, we have our electric engine, right? So our gearbox, gear reduction. We have our generator. We have our 3-cylinder petrol engine, right? And we have our fuel tank and our traction battery at the back. Oh. All right, so as I was saying, you have hybrid vehicle and the plug-in hybrid. So this one I got actually act as slightly different from the hybrid. So the plug-in hybrids, these cars mainly run on electricity, but also have a traditional fuel engine, so you can use petrol or diesel too if they run out of charge. Plug-in hybrid can be plugged into an electricity source to recharge their battery. So with a hybrid vehicle, you don't plug a hybrid vehicle into an external power source because we have our onboard charger, right? But when it comes on to a plug-in hybrid now, it's like you fuse an electric vehicle with an ICE vehicle, right? So what happens now, the vehicle can drive as a regular vehicle. So for instance, you choose not to charge this vehicle. You can just drive in regular mode with a traditional engine, drive go anywhere you want and just pour in your gas. As well as you can choose not to put any gas in it and just charge it and run on the electric side of it, right? And when you run out of charge, you have to plug it in back and charge it again. or you can fully charge it, full the tank, drive go mobile in electric mode or pure electric mode. And when you run out of charge, you just switch over to the engine and then you just drive come back. And once the engine switch over, it now go recharge back the battery because there are two separate units in one vehicle. So it's two different systems running in one vehicle. They have nothing to do with each other. So once you run out of charge, the ICE engine switch on and take over the journey until you reach your next charging station. Or if you choose to drive on the petrol engine, when you run out of gas, the electric mode chip in and then you drive come back home. If you run out of both of them, you have to either find a gas station or a charging station. But that one now got help the other. Alright. So everybody understand the difference between a plug-in hybrid and a hybrid. You know, right now, actually see it.
Yes, sir.
Alright. So, good. So these are the plug-in hybrid layouts. Alright, so we have our thermal system up front, which is cooling system. And we have our DC to DC converter, as I said, that act as an alternator. We have our power controls. Right, we have our regular auxiliary battery, onboard charger, electric generator. We have our electric traction motor, charge ports, just the same. Right, we have our internal combustion engine. So it will have all the stuff them where you normally find on a pure electric vehicle, and it will have all the stuff them where you normally find on a conventional vehicle. Right, so we have our traction battery pack around here, and as I can see with the plug-in hybrid or probably all hybrid use a smaller battery pack, traction battery or battery pack, right? Than a pure electric. The pure electric entire floor is undercovered, so you can just look on the picture and know say it's not a pure electric vehicle. It has some onboard generator or assist. And we have our traction battery pack at the back store electrical energy, while we have our fuel tank to store petrol, right? And then we have our fuel filler at the back. And the filler can be at the front, the back, it all depends on the manufacturer. And then we have our exhaust system just the same. But as I said, there's two separate systems, them don't rely on each other. Them can operate without, one can operate without the other. All right, so fuel cell electric vehicle. All right, so hybrid electric fuel cell electric vehicle, and that's the shortening right there, FCEV, are powered by hydrogen. They are more efficient than conventional internal combustion engine vehicles and produce no tailpipe emission. They only emit water vapor and warm air. All right, so in this case, instead of having carbon coming through the tailpipe, the only thing we're going to have is warm air and water because of the content that is being used, right? So As with other electric vehicles, fuel cell electric vehicle are equipped with regenerative braking system to capture the kinetic energy normally lost during braking and store it in the battery. All right, so with fuel cell, instead of we use gas, we use hydrogen. All right, and this is the layout of that. They have the same basic layout, thermal system or DC to DC converter, traction motor. And then we have our fuel cell stack. So these are the key component in this and the tank. So the fuel tank, hydrogen is in it, and as we know, that is fully pressurized. So these tanks are specially made to withstand the pressure that is within them. All right, and the advantage with the fuel cell vehicle now, unlike a pure electric vehicle, you know, so charging time can be up to an hour, depending on the type of charge, if it is a fast charge. While with a fuel cell vehicle, charging can be within 5 seconds. That is even faster than filling a gas tank. So as you roll on the fuel cell station, the hydrogen station, I should say, it's gonna take like 2 to 5 seconds to get a full tank. But the drawback to that is we don't have enough of these stations. I'm not even sure if we have one in Jamaica here. So it's in the developing stage, so it's not widespread as electric vehicle. But that's something we're probably gonna start to see more and more in the future. All right, so we still have our battery pack and we still have our filler and stuff like that. The filler is for the fuel tank, or the hydrogen tank, I should say, and the fuel cell. Yeah, I think as I go along, we'll see how the fuel cell work. All right. All right, so lithium ion battery versus hydrogen fuel cell electric vehicle, both of them. So all right, so on the left we have our pure electric vehicle, and on the right we have our fuel cell electric vehicle. So onboard charger. So we have, what's missing by now? All right, so you guys seen that, right?
Yes.
Oh, all right. So electric motor. So we have an electric motor on the front, right there, and then propels the car using energy from the battery. And this side, we have electric motor propels car using energy produced by a fuel cell stack, right? So one gets its energy from the battery, and the other gets its energy from the fuel cell. So even though it has a battery, it don't get its energy from the battery, it get its energy from the fuel cell, right? So lithium ion battery creates electrical current by moving between the negative anode and the positive cathode electrodes, right? So our cathodes over here, and our liquid electrolytes, charging, discharging. So charging going from cathode to anode, and vice versa for discharging. right? So on the fuel cell side, it's a fuel cell stack. So hydrogen gas, H2 intake. So we have, that's our anode, and H2 passes through the catalyst and split into proton, and that is H plus, and electrons, and that is E negative. So once it passes through the catalyst, it actually got split. So the H2 or the hydrogen got split into two, negative and positive protons and electrons. And so this is how you are going to get a negative and a positive, but you have to have a separator now. So once you have the negative and the positive, we are going to have a separator. We are going to split or block one of the elements. So protons are going to be able to pass through, while electrons are going to take a different route. And that's how we are going to end up with the two polarities, right? So electrolytes, protons can pass through electrolytes, electrons can't, so it have to take a different route, right? When it take a different route, that's how we end up now with our two polarities. So we have our hydrogen, and this is the fuel cell. That blue portion that was in the previous picture. So this is what is taking place within that system. So we have our hydrogen coming in, proton and electrons, right? And as it passes through electrolytes, protons can pass through the electrolytes, and electrons can pass through the protons can pass through, my bad again. Electrons cannot pass through electrolytes, so they take an external path. This creates an electrical current which powers the car. All right. So oxygen, O2 intake, and this is the cathode. Right. So this is how we end up with water now coming through the tailpipe. Now we have hydrogen. And then oxygen come fuse in the mix of that. Right? So we end up with water coming through the tailpipe, or warm air, or moist air. And so that's the chemical reaction now. So the chemical reaction creates water, and we end up with H2O. So you can see all the difference and how that works between the two.
Can that water, could you actually drink that water?
I think I gotta try that still. Would have to be in a desperate state. But may I say a survival. Yeah. Just like how would I
Okay.
catch sea water and then use it back as distilled water. Even though
Right.
we're not drink that water, but if push come to shove and we have to drink it, we are gonna drink it. Probably I gonna feel
Right.
bad at yeah.
Okay.
But not when you have options.
Okay.
All right, so
Sir, my question,
yeah.
although it's out that range right now still, what you think are the best can tools you use to work on the hybrid vehicle them?
All right. Artel actually I'm not sure if them launch it yet, but them actually have a scan tool where its sole purpose is to work with electric vehicles, whether it's hybrid or pure electric.
How you think about the launch scan tool X431?
Oh, well, we use a few launch, but I'm not a big fan of launch. For some reason, that's just my preference. And I like launch scan tool.
Cool.
Yeah. While I have other person who like it, but that's my personal preference. Artel, and you have other brands. You have Car, and you have Scanlan, Tapdan, and other so. But the Artel would be like the more affordable one. We can do a lot of stuff. The ranch good as well, but it's not my preference. So we have hybrid vehicle, and we have plug-in hybrid, and then we have mild hybrid. All right. So this is how the mild hybrid work now. So mild hybrid, also called micro hybrid, use a battery and an electric motor to help power the vehicle and can allow the engine to shut off when the vehicle stops, such as at traffic lights or in stop and go traffic, further improving fuel economy. My hybrid system cannot power the vehicle using electricity alone. All right, so in this case now, all of the other type of electric and hybrid vehicle that we discussed, the electric motor can actually propel the vehicle, but in a mild hybrid, the motor is not strong enough to propel the vehicle by itself. So in this case, the motor is just being an assistant to the engine. So it's like you're lifting a box and you just call somebody to give you a hand, right? So it's like a helper. But at the same time, you give it the feature for can stop, switch off. So in stop and go traffic, the engine can switch off. So you'd have a stop start system and all those other little features, which are will actually help you with fuel consumption. And the fact that you have a motor actually helping the engine to do work, the engine will command less stress, so it will command less fuel, or it will need less fuel to get work done. All right. So a mild hybrid, so we have a full, a full hybrid on the left, or a mild hybrid on the right, and as I can see, both of them have them 12-volt auxiliary battery engine, right? So what this picture is actually showing that with a mild hybrid, you can have like a bigger engine because the engine is what is going to actually propel the vehicle. So while we have probably a 1000cc engine or a 3-cylinder engine or a 1300, with a mild hybrid, you will find bigger engine in those, right? With the full hybrid, we have our gear reduction. We have our gear reduction right here, while with the mild hybrid, we still has a transmission. But between the engine and the transmission, we have our integrated starter generator. And that same starter generator is the same traction motor. So as I can see, it's sandwiched between the engine and the transmission. So it actually assisting the engine to send power to the transmission. And as I can see, with the full hybrid vehicle, it uses a 300 volts battery pack, for example, while with the mild hybrid, we have a smaller battery pack, and it's just a 42-volt battery pack. And the reason why it uses a smaller battery pack system is because the traction motor is not what we are going to use to propel the vehicle. It is just there for assisting, so we wouldn't need that big battery pack to be supplying current to that motor. because it is just an assistant. So as I can see, the mild hybrid is like a regular conventional vehicle with a small motor slap in between the transmission and the engine with a small battery pack at the back. It's a component of EV and hybrid vehicles. First up, we have our battery pack. So this is the energy reservoir that contains the energy the car will use to drive, operate the heating and cooling, and run all of the other lights and accessory. Typically, batteries use direct current electricity that must be converted to DC or alternating current before sorry about that. So batteries use direct current electricity that must be converted to AC or alternating current before being used in the electric motor. Right, so our traction motor, we use AC current. The AC compressor, it uses AC current as well, because with these electric vehicles, their compressors are electronic device, are electric motors, right? So we don't have our mechanical belt-driven compressor. We don't have our belt-driven water pump. All of those are electric and they use AC current. So we have to actually convert back that DC current to AC to operate those. So that is where the inverter converter actually comes into play, right? And the DC to DC converter, as I said, that change a higher DC voltage to a lower DC voltage to operate the lights, charge back the auxiliary battery and stuff like that. So all of the duty what the alternator will be doing, that will replace that duty, to take over that duty. Alright, so this is our battery pack, our traction battery. This is just one example of one, and as I can see, this is a small unit. This one you can find is under the back seat, at the back seat or in the trunk, depending on make or model. And then this is actually in a case, so you're not actually seeing the modules, right? It's in a case. Alright, so we have our power inverter. So when an EV has AC motor, the energy from the battery must be converted in order to be used. The inverter also operates when the car is using regenerative braking, converting the alternating current generated by the electric motor into direct current to be stored in the battery. And as we say, only DC current can be stored. That's why I'm a pause on this video. Stop interrupting. I'm not my pause between the slides. All right, so the power inverter. This is an example of one. And with the power inverter, we normally have high voltage DC current and low voltage DC current going through it, as well as DC current converting into AC current and AC going back to DC. So that's the purpose of this, and we actually have, and because it's going to be converting current back and forth, you know, that will generate a lot of heat. So actually have to have this on a cooling system. So you will have our inlet and outlet pipe for coolant right here. And with these, and like how we normally show like cheap coolant in our regular vehicle, and then clog up the pores or eat away our water jackets. With these, we only use what is recommended by the manufacturer. So if it is oil-based coolant, we use oil-based coolant, and it must be good oil-based coolant. We're not talking like those that one else say on the shelf and it just mark oil-based. When you dip your finger in it, you don't feel any oil. If you use like wrong cooling solvent in these, so it's going to eat away the inside, and then you're going to actually have water now entering where it should not be entering, and you can actually have a short circuit. And you know what happened after that. So we come on to this to use quality stuff. All right, so the power inverter function to change the direct current DC and the battery into an alternating current AC, and then this alternating current is used by an electric motor. In addition, the converter and an electric car also has a function to change the AC current when regenerative braking to DC and then use to recharge the battery. The type of inverter used in some electric car model is a bidirectional inverter category. So the bidirectional category, meaning you can go from AC to DC and then vice versa. All right. So its purpose is not only to change from DC to AC, but it can go the other way as well. As I can see the term bi. All right, the controller, the main function of the controller is a regulator of electrical energy from batteries and inverters that will be distributed to electric motor. While the controller itself gets the main input from the car pedal, which is set by the driver. So based on your pedal input, or the accelerator pedal input that is, the controller now go say, right, we need to supply this amount of voltage, and you know, say a voltage we're gonna use to control the speed of the motor. So like how we have our conventional vehicle, we use a throttle pedal to regulate airflow and fuel. So a wider open it, the throttle pedal, and more air will go in the engine and more fuel. So in this case, a more current will go send to the motor itself. And that I go tell if we actually need to go faster or slower. So that's why them say based on driver pedal input. So this pedal settings will determine the frequency variation or voltage variations that will enter the motor. All right. At the same time, determines the car speed. All right. So the pedal input, so I regulate the frequency variation of the motor. All right, so in brief, this unit measures the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. This component will determine how electric car works. All right. So it's the importance of that. So with this, we have no speed control, we have no control over the motor. So as I was saying, it's a regulator, voltage regulator, that is controlled by the driver input. So high voltage cables. So once we go around EVs and hybrid vehicles, and we see those orange cables, we know say those are high voltage cables. Hence the reason why they are in orange. All right. And as I can say, We have our insulated portion, outer case. Then we have steel braided lines, and that can actually cut down interference or interfering, just a second, magnetic fields. So that can cut down interfering magnetic fields, as well as it helps to cut down the magnetic field that is being created in these wire, because sometimes these wire pass over others. So it helps to suppress that magnetic field and keep it within this other insulated portion again. So you can see these wires are special. They are not just any cables. They are specially engineered for their purpose. So high voltage cables. This high voltage electric vehicle. So this high voltage electric vehicle screen cable is used for connecting the charging port and the battery inner winding, the battery, and the engine and other electrical component to carry the electric current power. So the screen EV cable is halogen free and coil resistant, oil resistant, and good EMI and EMC, electromagnetic interference ability, flame retardant as it passes vertical flame propagation. All right, so this cable can withstand all of what they actually stated in that last paragraph. All right. So an electric motor, otherwise known as a traction motor. So the component of an electric vehicle that transforms the electrical energy from the battery into rotation that can be used to move the vehicle. All right, so as we say, we can look at this as an actuator. As we say, a motor fall under the actuator category. What that do? What actuator does, it converts electrical energy into mechanical energy. We know say energy never destroy, just change form. Yes, so as I was saying, this component of an electric vehicle that transforms the electrical energy from the battery into rotational that can be used to move the vehicle. So unlike what ICE internal combustion engine, we have chemical engine energy going in, and that converted to mechanical energy. We have our pistons, and then we have our crankshaft that convert reciprocating motion. So it converts reciprocating motion into rotational motion, rotary motion, and then that goes to the road wheel. So as I can see with the traction motor, you don't need piston or crankshaft to do the same job. So that's why I would say use less moving parts. So the motor is the only part that is being moved in this case. So electric motor, because the controller provides electrical power from the traction battery, the electric traction motor will work turning the transmission and wheel. Some hybrid electric cars use a type of generator motor that perform the function of propulsion and regeneration. In general, the type of electric motor used in the brushless DC motor is a brushless electric motor, I think. Oh, I think so. Just a second. Yeah, sorry about that. Just make a quick adjustment. All right, so the gear reduction system. So as I can see, we have our traction motor attached to that. So that has our transmission. So as I can see, that's a 2-gear system, nothing much. And then as I can see, this portion here is our final drive, right? And this is this gear right here is actually for park. So I want to put the vehicle in park. We have a parking mechanism that actually locked into these to prevent the vehicle from running away. All right. So you can see how basic or how simple this system is versus a transmission itself. That will have a lot of solenoids, sensors, fluids, even though this uses fluids, but it's way more simple. So the transmission or reduction gear, the transmission transfer mechanical power from the electric traction motor to the drive wheel, and that it is only purpose. All right. So DC to DC converter, as you guys probably familiar with that by now. So the DC to DC converter, G. This one of electric car parts that to convert that's to convert higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run the vehicle accessories and recharge the auxiliary battery. All right. So as I said, this actually reduces the higher voltage that is coming from the traction motor and lower that to lower voltage to charge the auxiliary battery and power the lights and all the other accessories in the vehicle. All right. Sorry. All right, so and this is a picture of it. Yeah, so we have our cooling system pumping coolant around it to keep it cool. This is the next example of one. It is so the one on the left is a water cool system, and the one on the right is a air cool system. So you can see it has the cooling fins and a cooling fan, right? And we have our negative and positive terminals and that, and then we have our control signal wires over here. So them actually do the same thing, just that one is water cool and one is air cool. And that go depend upon manufacturer. But them carry out the same basic function. So free charging the auxiliary battery and powering accessories. Alright, we have a 12 volts battery here. In an electric vehicle, in an electric drive vehicle, the auxiliary battery provides electricity to power the vehicle accessories. Alright, so with them type of battery, some of them battery I go find them inside the vehicle itself. So whether it's under the back seat, in the trunk, or somewhere in the vehicle. So because I don't know, these batteries actually come with like a tube, a vent tube where vents the fumes from the battery when it is being recharged back out into the atmosphere. So as I can see with this, we have a positive terminal or a negative terminal. And this will be our vent tube. So you wouldn't want to be driving the car and you actually smelling battery sulfur while driving. But we as Jamaicans, 90% time when we replace this battery, we put in back a regular battery in it. Because a person like I said them now spend 300 years to buy back one battery. When them could have just spend 50 US or 7 grand and buy a tropical battery put back in it. Alright. And you are going to replace it and you choose not to buy but this battery, which it is recommended to buy back this battery because the way it charges, the characteristics of how it charges is way different. It charges slower, it charges with less voltage, so it don't need this high amperage to be going to it to get it charged. And the charge time is actually, the charge cycle or time is actually different than a regular battery. So the system are designed for actually charge the battery in a certain fashion. So when show a regular battery in it, even though it go work, it probably go show off the system itself. And then the disadvantage, we put in a regular battery in it, when those start to spill acid, you go find say either your floor, your car go start deteriorate or corrode, or the back part or your trunk or wherever it is. These battery don't spill acid. Some of them is actually absorbent glass battery, and some of them is lithium ion battery. So them use gel instead of electrolyte. And sometimes they are lighter. Alright, so here we have our charge port and our charger type. So based on region, the charger go varies. While some region will share charger, Tesla is the only one that don't share charger. They have their own charger. So Tesla would have been like the Apple right here. You know, we have an Apple charger, while Samsung charger can charge other devices, even though Apple is moving over to the Samsung charger now. But that is just like an example. So we have our type 1 charger, right? As I can see, we have the AC and the DC type, and that is North America, right? So the DC charger, the easiest way to identify a DC charger is with these two circles. So as I can see, the AC charger, type 1, AC charger, North America and Japan use the same charger. So a Japanese charger can charge the North American vehicle once it support the type 1 charging, right? And as I can see, when I go down to the DC fast charge, it has 2 additional ports, right? So it always have these 2 bigger terminal. So actually 2 big pins for fast charging. So that I go allow more current to flow versus the AC slow trickle charge or type 1 charger. So the type 1 charger are the slowest charge possible. So these are the ones where they plug in from overnight. And it probably take like the whole night and probably part of the next day. Right? And then we have the European type charger and the rest of the market. So this is the type 2 charger. Type 2. And as I can see, the AC up here and then the DC to that. And just add the 2 fast charge pins. But it's going to be a different charger though. So you have the type 2 one, and then the DC is the CCS2, right? And in China, we have the GB/T, and that's the AC, slow charge, and then the fast charge, as I can see. So as I was saying, to identify the fast charge, it's easy. You just look for those two big circles right there, or the two big pin, and I'll really see a circle. I just select two big pins. So yeah, you're gonna say that is a fast charger. And then the Tesla one is just a fast charger right through. Right? And sometimes you will get like for instance, so if you have a Tesla charger, you can use it to charge other vehicles from other region, but you would have to use an adapter. And if you use the other one, them charger Tesla, you would still have to use an adapter. So you can actually get charger adapter to actually use one charger charge the several vehicles. If you have more than one electric vehicle, and you don't need to buy like several different chargers, you can have the one charger with several adapters. So it's a good if you screenshot this, because probably them will bring up questions on this picture right here, the types of charger. Alright, so charging ports. So much like the access port for the gas tank in an internal combustion engine car, the charge port is the location. So the charge port is located. Oh, so it should be the charge port is location is where energy enters the car, right? So just like we have a gas tank where you have liquefied energy entering the fuel tank, is the same thing where you have electrical energy entering the vehicle to actually charge the traction batteries. All right, so that's an example of it right there. So as you can see, one of them is a fast charger and one of them is a slow charger. But bear in mind, like, you come across a Nissan Leaf. Nissan Leaf actually support both charging, so it carries actually two charging ports side by side. So if you have a slow charge, you use a slow charge connector and a slow charge port. And if you have a fast charge, you choose whichever port you want to do that. All right. And the charge port can be at the front of the vehicle, the back, the center, the fender, just about anywhere. Varies based on make and model. All right, so onboard battery charger. So most EVs have a battery charger built into the car for level 1 or level 2 charging. All right, so this AC charging. So this is AC charging, not DC fast charging. The charger is there to limit the total amount of power going into the battery to avoid damage to the battery or the electrical circuit the charger is plugged into. So so as I was saying, the onboard charger, it is only used when we actually supply charging the vehicle with AC voltage, right? So once it sends that you're going to use AC voltage, the onboard charger will come in and act as an inverter will flip that to DC, right? And it actually will recognize if they are using a slow or fast charge, type 1 or type 2 charge. because you have trickle charge, you have normal charge. So trickle charge is type 1. Normal charge, that charge at a faster rate, right? And then you have fast charge, which is direct current. So you're getting direct. So when you plug in a fast charger in the wall, the fast charger itself actually converts the AC to DC before it reaches the charging port, right? So the onboard charger now got need to play any role in the charging because it's actually getting DC voltage already. So because of that now, you're able to charge at a faster rate, right? Next component is our battery management system. So the battery management system, the electrical current flows in and out the battery to protect the battery and extend its life. All right, so basically what you're saying is the battery management system, BMS, manage the electrical current flow in and out of the battery to protect the battery and extend its life, right? So this is what is actually regulating the battery then, whether it is its temperature, the state of charge, and stuff like that. So every EV is going to have a BMS that is designed specifically for the battery in the car. Thus modifying the battery or adding a battery would prove to be quite difficult if the BMS is not also modified to compensate. So what I'm basically saying here is if you have a traction battery with say let's say 20 modules, right? And that push out 300 volts. And you say, all right, add some more battery modules to the system. So you gotta add like 10 more and bring up your voltage to like 400, just for example. It now actually serve any purpose doing that if you don't modify the module as well, because the module actually can compensate for that. So the module now have to actually reprogram or change, right? So if you upgrade the battery, the traction batteries, you have to upgrade the modules as well, or the BMS in other words, right? And that can be expensive, but if you have a certain goal where you want to achieve, you can do that. So if you try to get your vehicle to have a hedge over next one, and first, like I said, then how FEMA when I run stuff. Because you modify the nerds at a cost. So we have up next we have the cooling and heating system. If equipped, a thermal management system can extend the life of the battery. Cooling it while fast charging and on a hot day, and even warming it up on a cold day, or to prepare for fast charging. The TMS works for the BMS to create optimal battery condition. So in other words, the cooling and heating system of the traction battery, it is there to actually maintain the battery within certain operating temperature. So for example, if we have a cold day, the system can actually bring up the battery to operating temperature so it can fast charge or just charge overall. And if the battery temperature is getting too hot, we can lower the temperature, right? So we don't overheat the battery, because once you overheat the battery, we have a term we use as thermal runaway, right? So that says when we actually have the battery actually catching a fire.
So that system only works while the battery is charging, or it works while the car is driving as well.
Yeah, so it work while the car is driving. So I remember when the car is driving, the traction motor, if needed, I gotta use it. Plus, see, I gotta use auxiliary stuff like accessories. So yeah, I gotta have your radio on. Yeah, I gotta have probably air condition on, right? And all of that I gotta pull current from the battery. And then the battery in turn I forgot enough start to recharge back. So yeah, I got enough to generate heat in the system. So just like the engine, you have to maintain battery temperature just the same. All right. And it can be a case where the day is just hot. So it have to compensate for that day and cool back down the battery. So some of them is actually liquid cool, and some of them it actually have a suction fan actually pump air in between the individual battery cells or module, right? To maintain temperature. All right, so I was saying conventional vehicles would have like belt-driven accessories or components, but those are actually being replaced with electrical stuff or electrically driven accessories. So unlike a gas or diesel vehicle using accessory belt, the air conditioning, power steering, and other components uses electricity from the battery pack to operate. So light radio and other components typically use traditional 12-volt direct current. All right. So as I said, we are going to alternator replace the electrical components, AC compressor, the water pump, and well, regular vehicle actually start to use electric power steering. All right. So that one is not new. But electric water pump and other stuff, yeah, AC compressor. Mm. So EV have 90% fewer moving parts than an ICE internal combustion engine car. Here's a breakdown of the parts that keep an EV moving. Electric engine slash motor provides power to rotate the wheels. It can be DC, AC type. However, AC motor are more common, right? And then we have our electric, then we have our inverter. So inverter converters. So inverter converts the electric current in the form of direct current DC into alternating current, right? And we have our drivetrain. So EV have a single speed transmission, which sends power from the motor to the wheels. Then we have our batteries, store electricity required to run an EV. The higher the kilowatt, the higher the kilowatt of the battery, the higher the range. So the higher the kilowatt, the more range you have out of the battery. So it's just like having a bigger gas tank. So more liter, I guess I can actually put in it, the tank can actually hold, the farther the range. So higher kilowatt, more range. And then we have a charging. So plug into an outlet or EV charging point to charge your battery. So it back rid of the battery already. So, sure, so I do this slide already. Anyway, so regenerative braking. So in this system, the motor drives the wheels during acceleration or cruising, but the wheel drives the motor while decelerating. This two-way energy flow allows the motor to act as a generator, resisting the rotation of the wheel and creating electricity to recharge the vehicle's battery. So regenerative braking, I think this part of the slide for the All right, so regenerative braking. So there are two conditions when regeneration occurs. When the driver applies the brake pedal and when the driver releases the accelerator pedal and the vehicle is posting. All right, so once you look at the gas pedal, we have regenerative braking. So the motor will act as a resistance against the road wheel, and then that will create the energy and that will send to the battery once you touch the brake pedal or apply the brake. In both cases, the system creates electricity to recharge the battery. Drivers can view this regenerative effect on the vehicle charging gauge, which shows it as energy flowing from the wheel to the battery. So normally on the display, you would actually see the energy flowing from the wheel to the battery, and then when you start accelerate again, you will see energy flowing from the battery to the road wheel on the display panel. Right, so this is like an example of that. So region in electric vehicle. So this is with the brake being applied or accelerator pedal release. So you can see now energy is moving from the motor and going to from the wheel to the electric motor and generator attached to the inverter, because it says AC voltage coming back. Then it converts to DC and go back to the traction battery. When you apply the gas, it flows in the opposite direction. So from battery to inverter, electric motor to road wheel, region from road wheel to traction motor inverter, and then back to the battery. So it's like a reverse action when you're doing region. All right, so the region braking now. So the battery management system, and that run on the CAN high system. So the communication network uses the CAN high, right, in red. And then it uses CAN low as well. So you have a CAN bus system high and low. And all of these is actually communicating with each other. So brake controller. So this I gotta tell it when you apply the brake, and then that now I gotta send signal to the motor controller if it will actually put power or add power. And we have the vehicle controller as well. So all of them is in communicating with each other to actually control the vehicle itself. So between the controller and the brake so between the motor control and the brake controller, so this is the brake pedal, and this one is actually coming from the gas pedal. So when you let it go, this will get the signal say there is no frequency coming from the pedal, and then this will say, all right, the brake is applied, battery management system. I got send it signal now to the inverter, and then so everybody is working as one. Right? And as I said, based on pedal inputs, it can actually, where instead of use the region from the motor to slow down the vehicle, we're going to apply the actual calipers, where they use the calipers to slow down the vehicle, or the braking system itself to slow down the vehicle, or bring it to a full stop. So it's based upon inputs from all these controller. I got to determine what action needs to be taken. Right. So I think that's your close.
So
Fair enough.
for the regen braking,
Yeah.
like it could go over the part where you release a foot off the pedal to brake and charge the battery.
Again.
Or can I ask a question with regards to that as well? Once you take your foot off the gas, even if you don't touch the brake, will it start regenerating?
Yeah.
Recharge the battery?
Yeah, because I would say it's two conditions it actually do that under. Once you release the pedal, the gas pedal, or from I touch the brake. So any one of them you do. And by right, you always have to release the pedal to touch the brake. But you have but the reason why them actually split them, as we can say, once you release, chances are you're gonna touch the brake. But you have some of them electric vehicle actually can make a drive with one pedal motion. So it's like when you press the gas pedal, you propel the vehicle. If you ease up off of the pedal, you start draw back the vehicle. So the one pedal can be acting as brake pedal and gas pedal.
Oh, okay.
Yeah, so that's why them set two actions. So when the driver apply the brake, or when the driver releases the accelerator pedal. So if you are driving in a one pedal mode and you release the pedal, it will go slow down the vehicle. And so once you release the gas pedal, regen braking will take place. And when you touch on the brake pedal itself now, you're gonna see the rate of charge actually go up more on the display screen.
Oh, okay.
All right. And somebody that asked a question before that, never heard that one clear. Or is it the same question?
It was answered in that answer.
Oh. Yeah. So this should bring us to the end of this slide. And we can watch like tutorials online about hybrid and electric safety. So then we'll bring you through the same gloves, so you'll get like a video of that, so you'll get a better understanding and introduction to it, so you'll get the components in a more realistic form if you watch it on YouTube or something like that. So yeah, just bring across the knowledge a little bit more clearer. All right.
Okay.
Weber, you have this YouTuber we name Weber University. You follow it. You can actually get a lot of useful videos that him actually teach. So yeah, bring across the knowledge more clearer too, no? So you actually be seeing the components instead of seeing like these little squares with writing on it. You actually be seeing the actual components. Mm-hmm. All right, so when from so basic, she's going the same thing. I think same. So you can just close it off. So thanks for the time.
Thanks again, gentlemen.
You're welcome. Take care.
All right, and
Have a pleasant night.
You too.
it connected to Bluetooth, but I know right now it's speaking about and the settings of the rest of the article.